All right, Highland Pirates. This is Mr. Swart. I'm going to guide you through how to use a tool called Loopy. Loopy is a tool for thinking in systems. We're going to be using Loopy, and you can access Loopy, I should tell you, by either clicking on the link provided or typing in ncase.me/loopy, ncase.me/loopy into your browser, and it will take you here. All right, Loopy is a really cool tool. We're going to be using it to model the ecosystem, or at least a small part of the ecosystem, the food web of Yellowstone National Park. And we're going to get there by scrolling down this website about the halfway point, and we're going to play with the basic ecology example. So let's click on that together. All right, in this example, it's pre-built for us. They're giving us an example where we have rabbits and foxes together, and we're going to model the relationship between rabbits and foxes. So what you can see here, first off, the aspects of a network diagram that are really important. We have what are called nodes. So nodes are the circles, and we have edges. Edges are these arrows. Edges help us define the relationships between the nodes. You can see here that rabbits are food for foxes. When there's more rabbits, there's more food for foxes. So there's a plus sign, there's a positive relationship. The energy in the rabbits is going to be transferred to the foxes when the foxes eat the rabbits. When foxes eat rabbits, there's going to be fewer rabbits. So if we have too many foxes, they're going to be eating a bunch of rabbits, and the population of rabbits is going to decline. So there's a negative sign here, a negative relationship between foxes and rabbits. And we can see what this looks like. We can hit the play button, and we can actually observe this model in action. This model is showing us equal numbers of rabbits and foxes. So the size of the circle inside the node gives us a sense of the population size. It's not precise, but it's a good relative measure. All right, here we go. We're going to hit play. Let's say we've got equal numbers of foxes, and now there's a bunch of foxes. Let's click the up arrow on foxes. All right, we got a lot of foxes. Ooh, population of rabbits is going down. With fewer rabbits to eat, there are fewer foxes that can sustain themselves. When there's fewer foxes, there's more rabbits. And the cycle goes and it goes. So when there's fewer rabbits, there's less food for the foxes. So not all the foxes can survive. When there are fewer foxes, there's more rabbits that can reproduce, and then the population of rabbits increases. All right, I'm going to hit the stop button, and we're going to take and modify this. Let's modify this. Let's do this. Let's hit the erase tool. Let's practice with the erase tool. So we're going to click on that. Let's get rid of this note. We don't need that. Ooh, you know what? Let's just go big. Let's erase everything. Let's go crazy here. There, clean slate. All right, we've seen this in action. Now it's time to actually make our own model. We're talking Yellowstone, and the cornerstone of the work that we've been learning about so far are wolves. So let's take our pencil tool and draw something that looks like a circle. Just like that, we have a node. We've created a node, and the node is currently labeled with a question mark. Let's type in wolves. Oh, let's actually type it correctly, wolves. We can keep it red. And we know that in Yellowstone, there aren't too many wolves. So we'll make that our smallest amount. Just a few wolves, maybe 100 or so. All right, we're going to draw another node. Let's draw a node and label that one elk, because we know that wolves will eat elk. And let's change the color to orange. And let's say, what are there, around 2,000 elk? I think if I remember the numbers correctly. Let's add a few more elk. All right, so we'll click on the third largest, I should say the third circle from the left, so that the size of the elk circle is the third one over. Okay, and we know that wolves are going to eat the elk, and when wolves eat elk, the energy transfers from elk to wolves. Okay, so we've drawn edges and we've drawn nodes. Now we have to actually look and see if we've drawn our edge labels correctly. we know that the energy from elk is going to feed those wolves. And we know that when wolves eat elk, the population of elk is going to decrease. So this plus sign at the top, let's click on that. And let's change that relationship to where it says more and then less. So over here on the right, we're going to click on that button. And when we do that, you can see it goes from a plus sign to a minus sign. It changed. So the more elk there are, the more wolves there will be. As the wolf population increases, they're going to start eating more elk, which is going to negatively affect the elk population. And we can check that when we hit play. Let's say that we have an increase in the elk population, or I'm sorry, an increase in the wolf population. More wolves, fewer elk, fewer elk, fewer wolves, more elk, and on it goes. So we'll hit stop. Okay. We also know that elk eat certain types of trees in Yellowstone Park. We know that they eat aspen trees. So we'll type in aspen and let's make the trees green. And there's a bunch of aspen. And we know that they eat willow trees. So we can add some willow trees into our model. And they'll eat cottonwood trees. Let's add cottonwood. And let's say there aren't too many cottonwood trees at this point. Let's say the cottonwood tree population is that third node over. All right, and then we're going to draw some edges. We've just added 3 nodes, but they're just going to sit there unless we've connected them with our edges. So let's draw some edges between elk and aspen. And if aspen are food for elk, we've got to draw a node back, and we need to change that to a plus sign. So aspen feed the elk. When elk have the food, elk numbers increase, which then will have a negative effect on aspen. And we can do the same thing with cottonwood. Draw a node there, and willow. Draw a node there, going from willow to elk. We'll change the relationship more to less, and we're going to draw arrows back from elk to cottonwood and from elk to willow. Because when elk eat cottonwood or when elk eat willow, those populations are going to change. And I'm noticing that one of my nodes is a negative when I didn't want it to be a negative. There we go. So I'm going to change it to positive. All right. So my edges that are leaving from these 3 trees, aspen, cottonwood, and willow, those edges, those arrows are plus, right? They're pointing towards the elk because the energy is going to go from those trees to the elk. The elk are eating them. And when the elk eat those trees, they're going to have a negative effect on the number of those trees. So aspen should be a negative from elk to aspen, a negative from elk to cottonwood, and a negative with the arrow pointing from elk to willow as well. And that's a model. It's a simple model. It's very incomplete, but it's still a model. So let's go ahead and model it. Let's hit the play button and see what happens. Let's say that there's an increase in the elk population. Let's hit the elk button on top, the arrow pointing up. All right, we've got a bunch of elk. It's been a good year for elk. The elk were eating the trees. Population increased. This is a dynamic system. I'm gonna hit the stop button again. Okay. So you can see that the size of the circles inside these nodes are changing as time changes. So this is one of the things that we can use to keep track of. So as time progresses, as you let this model run for longer and longer, you can start to see the cumulative effects of these organisms on each other. One of the interesting things you can do with this tool is, let's say that the elk migrate to an area that has more aspen and cottonwood, but fewer willow. You can actually use this tool to model geography. Now, whether this is true or not is a whole nother story, but we can still model it. So let's find out what happens. Let's hit the play button. And let's say now we're having more elk. You can see it takes much, much longer for the arrows to travel from the elk to the willow than it does for the elk to the aspen or the cottonwood. So you can start to see the overall effects here. Currently, this system is showing lots and lots of elk. The elk population seems to have maxed out. And there's lots of aspen and cottonwood. The willow population is kind of changing quite a bit. The wolf population increases at times and then decreases. We're going to stop. Let's say that the wolves migrate further from the elk. And let's say that the elk now are migrating towards the willow. I'm using the hand tool to move things around. Let's play it again and see what happens. Again, we're going to increase the elk population. So when the elk population booms, it's followed by an increase in the wolf population. And when that wolf population jumps up, there's a negative effect on the elk population. And if the elk have access to plenty of food in terms of willow and aspen and perhaps cottonwood, then their population stays strong. You can see that the wolves on the left-hand side are kind of having these boom and bust cycles. I'm going to go ahead and stop it. All right. So at this point, you've had a chance to see some of the different things that Loopy can do in terms of modeling ecosystems or modeling networks. And so it's your turn. What I'm going to encourage you to do is model or add to this model the organism that you researched for your project. You can do that by taking the pencil tool and you draw a circle for a node, and then you can draw edges. Let's say you have an organism that also eats elk. Maybe you researched bears. So I'm going to change it to red because I know that bears like to eat elk. So I could rename this bears. Maybe you did grizzly bears. I'll be specific. Grizzly bear. And we know that grizzly bears are going to limit the population of elk. There's going to be fewer of those. And we know that elk are going to provide energy to grizzly bears. So that's a plus sign. And then we can hit the play button. Maybe you feel like that the proportion or the circle for grizzly bears is reasonable compared to wolves and elk. Maybe that's too big. Maybe we want to bring it down a notch. And then we can hit play. And let's see what happens if we increase that elk population again. And you can see our model starting to become increasingly complex. Suddenly we have tons of grizzly bears and wolves, but that's not sustainable if they eat all the elk. So then their populations decline and the elk population blooms. But while our elk population is low, you can see the effect on the trees that the elk tend to eat. So you can see this gets to be very, very complicated very, very fast. And we only added one extra organism. We only added grizzly bears here. I'm going to erase grizzly bears and it takes away the edges. So I want you to use this and add at least your organism, or get ambitious and add a few. You have access to some class data. So see if you can build out a model that is as complicated as you're comfortable modeling. And then we'll do some analysis working through the worksheet. All right, thanks for watching.